The K-129 was a Gulf II class diesel-electric ballistic missile submarine, one of the most advanced vessels in the Soviet Navy at the time. It was armed with 3 R-21 ballistic missiles, each capable of carrying a 1 megaton nuclear warhead, powerful enough to devastate entire cities. Welcome to a journey deep into one of the most daring and expensive covert operations in history, Project Azorian. This $4 billion secret mission was designed to raise a lost Soviet submarine from the depths of the ocean. But what exactly is Project Azorian? Why was it so crucial that it had to be kept under wraps? And how did a mission of this magnitude even come to be? In today's episode, we're diving into the mystery behind this clandestine operation. We'll explore why this mission cost a staggering $4 billion and what made this Soviet submarine so important. You might be wondering, did they succeed in raising the submarine? Or what incredible technology was used to lift it from the ocean floor? Don't worry, you're in the right place. All these questions and more are about to be answered. But that's not all. What if I told you that what was inside the submarine could have sparked a global crisis? Or that some aspects of the project remain classified to this day? We'll also delve into the political implications, the untold secrets, and the incredible story of those who carried out this mission. Because the truth behind Project Azorian is more shocking than you could ever imagine. By the end of this video, you'll not only know the full story, but also understand why this mission changed the course of history. But before we do that, give us a thumbs up if you like our video, hit that subscribe button down below, comments in the comment section below. As for the significance of Project Azorian, it's essential to dive deep into the Cold War, a period of intense and often perilous geopolitical rivalry between the United States and the Soviet Union that spanned from the end of World War II in 1945 till the dissolution of the Soviet Union in 1991. This era was defined by a global struggle for supremacy between two ideologically opposed superpowers, the capitalist democracy of the U.S. and the communist regime of the Soviet Union. The world was divided into spheres of influence, with each superpower vying for control, often through proxy wars, espionage, and a relentless arms race. The Cold War was the doctrine of mutually assured destruction, a chilling concept that ensured if one side launched a nuclear attack, the other would respond in kind, leading to the total annihilation of both nations and likely much of the world. This precarious balance of power meant that both the US and the Soviet Union were constantly seeking any advantage, technological, military, or intelligence, that could tilt the scales in their favor without triggering a full-scale nuclear war. The oceans, vast and deep, became critical theaters in this struggle. Submarines, particularly those capable of launching nuclear missiles, were central to both the nations' deterrence and first-strike capability. These stealthy underwater vessels could hide beneath the ocean's surface, undetected by enemy forces, and were capable of delivering devastating nuclear strikes on key targets across the globe. As such, they were among the most closely guarded and strategically important assets in both the US and Soviet arsenals. For the Soviet Union, submarines like the K-129 were not just tools of war, they were symbols of national pride and technological prowess. The Soviet Navy, under the direction of Admiral Sergei Gorshkov, had been rapidly expanding its submarine fleet to challenge US dominance of the seas. The Soviet military doctrine emphasized the importance of a robust submarine force capable of patrolling international waters, gathering intelligence, and if necessary, launching surprise nuclear strikes against the West. This on submarines were part of a broader Soviet strategy to project power and influence globally. The Cold War was not just a contest of military might, it was also a battle of ideologies, with each superpower seeking to demonstrate the superiority of its system to the world. For the Soviets, maintaining a formidable submarine fleet was a way to assert their place on the global stage and to ensure that they could defend their interests in the event of a direct conflict with the US. Against this backdrop, in early 1968, the Soviet submarine K-129 embarked on what was intended to be a routine mission in the Pacific Ocean. The K-129 was a Gulf II class diesel-electric ballistic missile submarine, one of the most advanced vessels in the Soviet Navy at the time. It was armed with 3 R-21 ballistic missiles, each capable of carrying a 1 megaton nuclear warhead, powerful enough to devastate entire cities. The mission of K-129 was to patrol a region where it could strike at the U.S., should the order ever be given. On March 8, 1968, K-129 failed to make its scheduled radio check-in with the Soviet Naval Command. When it didn't respond to repeated attempts to contact it, the Soviets launched an extensive search operation, scouring the Pacific Ocean for any sign of the submarine. Despite their efforts, K-129 was nowhere to be found. The submarine and its crew of 98 men had seemingly vanished without a trace. The disappearance of K-129 was a significant blow to the Soviet Navy. Losing a submarine was not only a tragic loss of life, but also a severe setback in their Cold War strategy. The reason for the submarine's loss remains shrouded in mystery, fueling speculation and conspiracy theories. Some believe that K-129 may have suffered a catastrophic mechanical failure, while others suggest it collided with a U.S. submarine. There are even more outlandish theories that propose K-129 was attempting an unauthorized nuclear strike or was the victim of sabotage. For the Soviet Union, the loss of K-129 was a closely guarded secret. The last thing they wanted was for the U.S. to discover the location of the wreck, and worse, recover its contents. The submarine was not just a military asset, it was a repository of highly classified technology and information. Inside the K-129 were not only nuclear missiles, but also codebooks, encrypted communication devices, and possibly even documents detailing Soviet naval strategies and operations. This information fell into American hands, it could shift the balance of power in the Cold War. Unbeknownst to the Soviets, however, the U.S. Navy had detected the explosion that caused K-129 to sink. An array of underwater listening devices, part of a top-secret program called U.S surveillance system, the U.S. was able to locate the wreckage of K-129 approximately 1,500 miles northwest of Hawaii at a depth of over 16,000 feet. A discovery of immense significance. The U.S. now had the opportunity to recover the submarine and its potentially priceless cargo of intelligence. But this was no ordinary salvage operation. Recovering a submarine from such a depth was a challenge that had never been attempted before. The mission would require cutting-edge technology, unprecedented secrecy, and immense resources. It was a gamble, one that would eventually lead to the creation of Project Azorian, a mission that would push the boundaries of what was technologically possible and test the limits of Cold War brinksmanship. Interest in the K-129 extended beyond its role as a ballistic missile submarine. The vessel represented a rare opportunity to gain first-hand access to the most advanced Soviet military technology of the time. At a depth of over 16,000 feet, the K-129 was a vault of top-secret materials that had never been within American reach. The value of this submarine to U.S. intelligence was not merely theoretical. It was a chance to directly acquire and analyze components of the Soviet Union's strategic deterrent. One of the key elements the U.S. hoped to recover was the submarine's central control systems. These systems could provide insights into the operational protocols of Soviet ballistic missile submarines, including launch procedures, command and control hierarchies, and fail-safes. Understanding how these systems were engineered and how they functioned under real-world conditions could have offered the U.S. critical information on the reliability and vulnerabilities of the Soviet Union's nuclear forces. Another significant aspect was the onboard cryptographic equipment. During the Cold War, both the U.S. and the Soviet Union employed sophisticated methods to encrypt their communications. If the cryptographic machines or codebooks used by K-129 were recoverable, they could unlock a trove of Soviet military communications. With access to such equipment, U.S. cryptographers could potentially decipher past and future Soviet messages, thereby gaining an unprecedented window into Soviet military strategy and decision-making processes. The submarine's sonar systems were also of great interest. Sonar was essential for navigation, communication, and detecting enemy vessels, particularly in the vast open waters of the Pacific. Using the K-129 sonar technology, U.S. engineers could assess the effectiveness of Soviet submarine detection capabilities. This knowledge could then be used to improve U.S. sonar systems, making American submarines more stealthily and harder to detect by Soviet forces. Additionally, the K-129 was likely equipped with advanced navigation equipment, including gyroscopes and inertial navigation systems. These devices were for maintaining the submarine's position and course, especially when submerged for long periods. Recovering and studying these systems could have provided valuable information on Soviet navigation techniques, including the accuracy and resilience under various conditions. Such insights could have been used to enhance U.S. navigational technology or to develop countermeasures that would disrupt Soviet navigation during a conflict. The structure of the submarine itself was another target for analysis. By examining the materials and construction methods used in the K-129, architects could learn about Soviet advancements in submarine design, particularly regarding hull integrity, noise reduction, and deep-sea capabilities. This information could then be used to inform the design of the future U.S. submarines or to exploit potential weaknesses in Soviet vessels. Lastly, the potential recovery of nuclear materials was of significant concern. The K-129's missiles were armed with nuclear warheads, and the U.S. was eager to recover these to analyze their design and composition of the fissile material. Understanding the yield, composition, and delivery mechanisms of these warheads could provide crucial data on the Soviet Union's nuclear capabilities. Moreover, recovering these warheads would prevent them from becoming a potential environmental hazard or falling into the hands of other nations. To recover the K-129 was driven by a unique convergence of strategic and intelligence imperatives that made the risks appear justifiable in the eyes of U.S. leaders. At its core, the U.S. viewed the K-129 as an unparalleled opportunity to gain a deeper understanding of Soviet capabilities and intentions during a time when the Cold War was at its most intense and unpredictable. From an intelligence standpoint, the potential recovery of Soviet nuclear missiles was a priority. Design and construction of these missiles, American scientists and engineers could glean insight into the Soviet Union's nuclear technology. This included understanding the materials used in the warheads, the range and accuracy of the missile delivery systems, and the technological advancements the Soviets had made in miniaturizing and hardening their nuclear payloads. Intelligence would have immediate applications for U.S. military defense systems, helping to develop effective countermeasures and ensuring that American intelligence would have immediate applications for U.S. military defense systems, helping to develop more effective countermeasures and ensuring that American nuclear deterrence remained credible and superior. Technology, the K-129 likely housed encrypted communication devices and critical codebooks which were the lifeblood of Soviet naval operations. Recovering these items would have provided the U.S. with a direct line into Soviet military communications. Decoding these encrypted messages would not only reveal past and current operation details, but could also allow the U.S. to anticipate future Soviet naval movements and strategies. This would enable the U.S. to disrupt or neutralize Soviet operations before they could pose a threat. American forces a significant tactical advantage in any potential conflict. Moreover, 29 represented a rare chance to study the operational doctrine of the Soviet Navy. Using the layout of the submarine, the positioning of its crew, and any onboard logs or documents, U.S. intelligence could reconstruct the Soviet approach to submarine warfare. This included understanding how Soviet submarines were deployed, how they coordinated with other naval and air assets, and how they planned to execute their missions in wartime scenarios. Such knowledge would be invaluable in countering Soviet strategies, whether in terms of direct confrontation or in broader Cold War engagements. The decision to pursue the recovery was fraught with immense risks, both technical and geopolitical. Technical challenges were staggering. 29 lay at a depth of over 16,000 feet, far deeper than any previous salvage operation had ever attempted. To put this in perspective, the pressure at such depths is crushing, about 7,000 pounds per square inch, meaning that any recovery effort would require engineering solutions that had never been tested in such extreme conditions. The U.S. needed to design and build specialized equipment capable of withstanding these pressures while also being precise enough to lift a large, fragile object from the ocean floor without destroying it in the process. The technological innovation required was immense, involving advanced robotics, hydraulics, and a highly specialized recovery vessel, all of which had to be developed in secrecy. Financially, the project represented a massive investment. The estimated $4 billion cost was an enormous sum, particularly for a mission with no guarantee of success. The U.S. government had to weigh the potential return on this investment against the many other demands on its defense budget. During a time when the U.S. was heavily involved in the Vietnam War and other global commitments, making the allocation of such vast resources to a single covert operation a significant gamble. Geopolitical risks were equally daunting. If the Soviet Union discovered the U.S. effort to recover the K-129, it could lead to a major diplomatic crisis. The Soviets would undoubtedly view this as a violation of international law and an aggressive act of espionage. This could escalate tensions at a time when the threat of nuclear war was always looming in the background. The U.S. had to carefully calculate whether the potential intelligence gains justified the risk of provoking a hostile Soviet response, which could range from diplomatic protests to military countermeasures. The mission was paramount. If it became public knowledge, it could not only derail the operation, but also lead to long-term damage to U.S. Soviet relations. There was also the risk of failure, which could take many forms. The technical failures, such as equipment malfunctioning, submarine breaking apart during recovery, would result in the loss of billions of dollars and possibly expose the mission. Or a failed recovery attempt could leave behind evidence that the Soviets could discover, further complicating international relations. Additionally, the risk of detection by Soviet intelligence, either through surveillance or other means, was a constant concern. Any hint of the mission's true purpose could lead to the Soviets deploying their own assets to monitor or interfere with the recovery effort, increasing the likelihood of confrontation. Considerable risks, the potential rewards were deemed worth the gamble. The intelligence that could be extracted from the K-129 had the potential to shift the balance of power in the Cold War. The U.S. with insights that could give it a strategic edge over the Soviet Union for years to come. A rare opportunity, one that could not be replicated, and one that, if successful, could provide invaluable data on Soviet capabilities that might otherwise remain hidden. Ultimately, the decision to recover the K-129 was made with full knowledge of the risks involved. It was a calculated risk, one that reflected the high-stakes nature of the Cold War, where the pursuit of even the slightest advantage could justify enormous expenditures of resources and the assumption of significant dangers. The mission that followed, Project Azorian, would become one of the most ambitious and secretive operations ever undertaken by the U.S. government, a testament to the lengths both superpowers were willing to go in their struggle for global dominance. The genesis of Project Azorian began with the discovery of the K-129 and the subsequent realization that this was an unprecedented opportunity to gain a significant advantage over the Soviet Union during the Cold War. The CIA, recognizing the strategic importance of the submarine and the potential intelligence it held, quickly began formulating a plan to recover it from the ocean floor, a feat that had never been attempted at such depths. The formation of the plan was spearheaded by a small elite group within the CIA's Directorate of Science and Technology. The division was responsible for some of the agency's most innovative and technically complex operations. The extreme depth at which the K-129 lay, over 16,000 feet below the surface, the task was immediately recognized as a formidable challenge. Traditional salvage methods were out of the question. The CIA needed to invent entirely new technologies and methods to accomplish the mission. The initial phase of the plan involved extensive feasibility studies. The CIA brought in experts from various fields, including oceanography, naval engineering, and materials science, to assess the viability of recovering the submarine. These experts determined that it would be possible, but only with the development of highly specialized equipment capable of operating under the immense pressures of the deep sea. The concept of using a massive ship equipped with a special design recovery system began to take shape during these early meetings. Consider how to keep such a large-scale operation secret. Building a vessel the size of the proposed recovery ship would inevitably attract attention. Suspicion could lead the Soviets to discovering the true purpose of the mission. The CIA's leadership understood that without an airtight cover story, the operation could be compromised before it even began. This is where the idea of involving Howard Hughes came into play. Hughes was a larger-than-life figure, known for his ventures in aviation, film, and industry. He was also notoriously reclusive and eccentric, traits that made him the perfect candidate for a cover story. The CIA approached Hughes with a proposal. He would publicly take on the role of sponsor for a deep-sea mining operation to harvest valuable minerals from the ocean floor. This would provide the necessary cover for the construction and deployment of the recovery ship. Hughes was an ideal choice, not only because of his public persona, but also because of his existing interest in advanced technologies and engineering projects. Gave the operation a veneer of legitimacy that few other figures could have provided. The cover story was carefully crafted to appear as a plausible commercial venture, one that was ambitious enough to explain the construction of a massive and technologically advanced vessel without raising suspicion. The Glomar Explorer, as the recovery ship was eventually named, was designed and constructed under the guise of this deep-sea mining operation. The CIA contracted with Hughes' company, the Summa Corporation, to handle the project, further solidifying the cover story. The ship was built in such a way that it could possibly be used for mining with equipment that, while ostensibly designed to collect manganese nodules, was actually intended to recover the K-129. One of the most critical pieces of equipment on the Glomar Explorer was the capture vehicle, also known as the Claw. This device was designed to be lowered to the ocean floor, where it would latch onto the K-129 and lift it into the surface. The engineering challenges involved in creating this device were immense. The Claw had to be incredibly strong, yet precise enough to avoid damaging the submarine during the lift. The design also included mechanisms to handle the possibility that the submarine might break apart during the ascent, jeopardize the entire operation. Planning and construction phases, the CIA maintained a tight lid on the operation. Only those with a need to know were briefed on the true nature of Project Azorian. This compartmentalization was crucial to ensuring that the mission remained secret from the Soviets, but also from other parts of the U.S. government and military. The level of secrecy was such that many of the workers involved in the construction of the Glomar Explorer believed they were genuinely building a mining ship, unaware of the CIA's true intentions. The CIA also took steps to manage the public perception of the project. Press releases and public statements the commercial nature of the operation, focusing on the potential economic benefits of deep-sea mining. The narrative was bolstered by Hughes' reputation as an industrial pioneer, making it easier to sell the story to the media and the public. The CIA even conducted disinformation campaigns to further obscure the operation's true purpose, misleading information to those who might have become curious about the project. As the Glomar Explorer neared completion, the CIA's planning entered its final stages. The operation was timed to coincide with periods of low Soviet naval activity in the Pacific, minimizing the risk of detection. The ship's mission was carefully choreographed to ensure that it could reach the recovery site, conduct the operation, and return without rousing suspicion. It also developed contingency plans in case the mission was compromised, including methods for scuttling the ship and destroying sensitive equipment if necessary. In essence, the creation of Project Azorian was a masterclass in Cold War espionage and innovation. It involved the development of cutting-edge technology, the orchestration of a complex cover story, and the coordination of numerous moving parts, all while maintaining an unprecedented level of secrecy. The operation exemplified the lengths to which the CIA was willing to go in its quest to gain an advantage over the Soviet Union, blending technical ingenuity with strategic deception in one of the most ambitious covert missions ever undertaken. The construction of the Glomar Explorer were feats of engineering driven by the specific demands of Project Azorian, a mission that required not only unprecedented technical innovation, but also a vessel capable of performing under extreme conditions while maintaining absolute secrecy. The Explorer was conceived as a one-of-a-kind ship, purpose-built to achieve a singular objective: covert recovery of the Soviet submarine K-129 from the abyssal depths of the Pacific Ocean. Explorer's construction began with a fundamental challenge: the need to create a ship large enough to house the massive equipment necessary for deep-sea recovery while being stable enough to operate in some of the most treacherous waters on the planet. The ship was designed with an exceptionally wide beam and deep draft, giving it the stability needed to manage the delicate operation of lifting a heavy damaged object from such an extreme depth while causing it to disintegrate under its own weight. Glomar Explorer was reinforced with high-strength steel designed to withstand the immense stresses that would be placed on the vessel during the recovery operation. The ship's superstructure was carefully engineered to accommodate the towering derrick and the vast array of equipment required for the mission, including the massive winches, cables, and pulleys that would be used to haul the submarine from the seabed. This superstructure was also designed to support the weight of the capture vehicle and the submarine as they were lifted, ensuring that the ship remained stable and level throughout the operation. The Glomar Explorer was its dynamic positioning system, which was critical to the success of the mission. This system, one of the most advanced of its time, allowed the ship to maintain a fixed position above the recovery site without the use of anchors, a necessity given the depth of the operation. It utilized an array of thrusters positioned around the hull, each controlled by a central computer that made continuous adjustments to counteract the forces of wind, waves, and currents. The precision of this system was essential, as even the slightest deviation from the ship's position jeopardized the recovery effort. Central to the Glomar Explorer's capabilities was its massive derrick, which stood over 200 feet tall and was designed to handle the enormous loads involved in the recovery operation. The derrick was equipped with a series of high-capacity winches and pulleys. specifically engineered to lower and raise the capture vehicle, like apparatus designed to grip the submarine. Were capable of exerting thousands of tons of force necessary to lift the submarine from the ocean floor, while the pulleys were designed to distribute this load evenly, minimizing the risk of equipment failure during the critical lifting phase. The moon pole was another innovative feature essential for maintaining the secrecy of the mission. This large open well was located in the center of the ship and allowed the capture vehicle and the submarine to be brought up inside the ship's hull, out of sight of any potential observers. The moon pole was equipped with sophisticated seals and doors that could close off the well once the submarine was inside, protecting the operation from prying eyes. This feature not only ensured that the mission could be conducted in secrecy, provided a controlled environment for handling the submarine once it was aboard. Remarkable aspects of the Glomar Explorer was the capture vehicle itself, a marvel of deep-sea engineering. The vehicle, sometimes referred to as the Claw, was designed to operate at depths of exceeding 16,000 feet, when the pressure is more than 7,000 pounds per square inch. The vehicle was constructed from specially developed alloys that could withstand these extreme pressures without deforming. It was also equipped with multiple hydraulic arms, each ending in a massive claw that could grip the submarine securely without causing it to break apart. Power systems were another critical component designed to provide the immense energy required to operate the winches, thrusters, and other heavy machinery involved in the recovery. The Glomar Explorer was equipped with multiple generators capable of producing enough power to run a small city, ensuring that the ship could sustain its operations over the extended period required to complete the mission. These generators were housed in specifically designed compartments to minimize noise and vibrations, which could interfere with the sensitive equipment used during the recovery. The mission of Project Azorian was the culmination of years of covert planning and advanced engineering, culminating in one of the most ambitious intelligence operations of the Cold War. The mission to recover K-129 was a high-stakes endeavor where every detail had to be meticulously managed to ensure success while avoiding international scrutiny. The timeline leading up to the deployment of the Glomar Explorer was characterized by intense preparation and strategic timing. In the months before the mission, the CIA worked in close coordination with various government agencies and contractors to finalize the ship's design, construction, and conduct rigorous testing. These preparations were essential as the operation required flawless execution to succeed. By early 1974, the Glomar Explorer was ready. The ship, docked at a secure location, was loaded with the last of its specialized equipment, including the capture vehicle and deep-sea monitoring systems. To maintain the cover story, all activity was conducted under the guise of a deep-sea mining expedition, with minimal public attention. In 1974, the Glomar Explorer set sail. The timing of the departure was carefully planned to coincide with a period of reduced Soviet naval activity in the Pacific, the risk of detection. As the ship made its way to recovery site, it followed a route that avoided heavily trafficked shipping lanes and areas of Soviet naval patrols. Throughout the journey, the crew adhered to strict operational security protocols, maintaining a low profile and limiting communication with the outside world. Upon reaching the designated recovery site, the ship's dynamic positioning system was activated, ensuring that the Glomar Explorer could hold a precise position directly over the K-129 wreckage. This system, a significant technological advancement at the time, was critical for the mission's success, as even a minor drift could disrupt the delicate operation about to take place. Once the Glomar Explorer was in position, the mission entered its most perilous phase. The capture vehicle, an intricately designed claw, was carefully lowered into the ocean. This descent took several hours, during which the crew monitored the vehicle's progress through a complex array of sensors and cameras. The depth of over 16,000 feet presented extraordinary technical challenges. The vehicle had to navigate through layers of increasingly cold, dark water, where the pressure was so immense that it could easily crush most materials. The first technical difficulties encountered was related to the capture vehicle's sonar and navigation systems. As the vehicle approached the seafloor, it began to encounter unexpected interference. The rugged terrain and debris on the ocean floor made it difficult to get clear sonar readings, crucial for locating the exact position of the K-129. The crew had to rely on a combination of sonar data and visual feeds from cameras to guide the vehicle, making the process slower and more nerve-wracking than anticipated. Was another critical concern. Throughout the operation, the possibility of Soviet detection loomed large. The CIA and the crew of the Glomar Explorer had prepared for this, but the reality of maintaining absolute secrecy in such a remote and isolated environment was daunting. The ship operated under a strict radio silence policy using encrypted communication only when absolutely necessary. This created additional stress as the crew had limited ability to communicate with their superiors or request additional support if needed. Moreover, there was the constant fear that a Soviet vessel might appear unexpectedly. The North Pacific was a vast area, but the Soviet Union maintained a significant naval presence there. The Glomar Explorer had to avoid detection not only by Soviet ships, but also by reconnaissance satellites, which could have potentially spotted the unusual activity on the ocean's surface. It coordinated with U.S. military and intelligence assets to track Soviet movements, but the unpredictable nature of the sea crew had to be prepared to abort the mission at any moment. Their vehicle made contact with K-129, another set of challenges arose. The submarine had been lying on the ocean floor for several years, and its condition had deteriorated significantly. The structure was fragile, with parts of the hull corroded and weakened by the pressure and cold. The crew had to carefully maneuver the capture vehicle's claws to avoid crushing the submarine or causing it to break apart. This required precise control of the vehicle's hydraulic systems, as well as real-time adjustments based on feedback from the sensors and cameras. A methodical lifting process began once the vehicle had secured a grip on the submarine. This was perhaps the most nerve-wracking part of the operation. The crew had to lift the wreckage at a painstakingly slow pace, inch by inch, to prevent the structure from collapsing under its own weight. The winches and cables were under immense stress, and the risk of a catastrophic failure was ever present. Despite these formidable challenges, the Glomar Explorer eventually succeeded in raising a significant portion of the K-129. However, the operation did not go entirely as planned. During the ascent, a portion of the submarine broke away, and only a section of the wreckage was successfully brought to the surface. This partial success was a mix of triumph and disappointment for the crew and the CIA. The section that was recovered included parts of the missile compartment and sections of the forward hull. The entire submarine was not recovered. The operation still yielded valuable intelligence. The materials brought aboard the Glomar Explorer were immediately secured in the ship's specially designed storage areas, where they could be examined in a controlled environment. The recovered section contained a variety of equipment and components that provided the U.S. with critical insights into Soviet submarine technology. This included parts of the submarine's missile guidance systems, communication equipment, and sections of the pressure hull which offered a glimpse into Soviet engineering techniques. Additionally, the remains of several crew members were found within the wreckage. These remains were treated with respect, and the decision was made to bury them at sea, a gesture intended to honor the fallen sailors, while maintaining the secrecy of the mission. Evidence gathered from the recovered materials was analyzed by experts from the CIA, the U.S. Navy, and other government agencies. Although the operation did not yield the full payload the CIA hoped for, the information obtained was nonetheless significant. It provided the U.S. with a better understanding of Soviet missile technology, naval operations, and the construction of their ballistic missile submarines. This intelligence contributed to the broader strategic picture that U.S. military planners relied on during the Cold War. The partial success of Project Azorian was kept under tight wraps for years, with only a small circle of officials aware of the mission's true nature. The secrecy surrounding the operation was so effective that it wasn't until much later that the public began to learn about the extraordinary lengths to which the U.S. had gone to recover K-129. Even then, details remained classified, with many aspects of the mission still shrouded in mystery. And international implications of Project Azorian were profound, particularly in the context of the Cold War's delicate balance of power. The mission to recover the K-129 was not just a technical and intelligence operation, but also a high-stakes gamble on the realm of international diplomacy. The Union's response to the discovery of the mission, both publicly and privately, had significant repercussions for U.S. Soviet relations and the broader dynamics of the Cold War. When the Soviet Union first became aware of some unusual activities involving the Glomar Explorer, the reaction was one of suspicion and concern. They were aware that the U.S. had some knowledge of the location of the K-129, but they did not fully grasp the scale of the recovery operation that was being undertaken. Publicly, the Soviet Union remained silent, likely due to the sensitive nature of the submarine's mission and the desire to avoid drawing international attention to the incident. Were keenly aware that any public acknowledgement of the K-129's loss or the U.S. recovery attempt could expose vulnerabilities in their naval operations and invite scrutiny from other nations. Privately, however, the Soviet government was alarmed. They understood the strategic importance of the K-129 and the potential catastrophic consequences if the U.S. had successfully recovered its nuclear missiles, codebooks, or other sensitive materials. Leadership likely engaged in intense internal discussions about how to respond. They considered the possibility of publicly accusing the U.S. of violating international law and engaging in an act of aggression. However, the Soviets were also weary of the international fallout from such an accusation, forced them to admit the loss of a ballistic missile submarine armed with nuclear weapons, a significant embarrassment on the world stage. The Soviets chose a more restrained approach. They closely monitored U.S. naval activities in the Pacific and increased their own naval patrols in the region. The intelligence apparatus also likely intensified its efforts to gather more information about the Glomar Explorer and its true mission. While they refrained from taking overt action, the discovery of Project Azorian undoubtedly heightened the Soviets' distrust of the U.S., forced their perception of the Cold War as an existential struggle where no opportunity could be missed. On a broader level, Project Azorian intensified the Cold War arms race, particularly in the realm of submarine warfare and naval intelligence. The mission underscored the strategic importance of undersea operations and the critical role that submarines play in the nuclear deterrence strategies of both superpowers. In response, the Soviet Union likely increased its focus on improving the stealth, survivability, and capabilities of its submarine fleet, while also enhancing its anti-submarine warfare tactics to counter the perceived threat from U.S. naval forces. Moreover, the operation highlighted the importance of intelligence gathering and the risks associated with losing sensitive military assets. Both the U.S. and the Soviet Union became even more vigilant in protecting their submarines and other critical military technologies from potential adversaries. Shadowy work of espionage, already a complex and dangerous game, became even more intense as each side sought to outmaneuver the other in the quest for technological and strategic dominance. In the years that followed, the legacy of Project Azorian influenced the strategies and policies of both nations. The U.S. continued to invest heavily in covert operations and advanced technologies designed to gather intelligence on Soviet capabilities, while the Soviets remained deeply suspicious of U.S. intentions and actions. This mutual distrust and the constant threat of escalation defined the Cold War era, with both superpowers a cycle of competition that extended beyond traditional military engagements into the realm of intelligence, technology, and covert operations. The surrounding Project Azorian was so tightly controlled that even within the U.S. government, only a select few were aware of the mission's true nature. For years, the operation remained one of the most closely guarded secrets of the Cold War. However, as with many covert operations, the veil of secrecy eventually began to lift, leading to the declassification and public acknowledgement of the mission, albeit in a carefully managed way. The first hints of Project Azorian came to light in 1975 when journalist Seymour Hersh published an article in the New York Times that touched on the CIA's secretive deep-sea mission. This was the first time the public heard about the U.S.'s efforts to recover a Soviet submarine, though the full details of the operation remained obscured. In response to inquiries about the mission, the CIA and U.S. government officials issued what has since become known as the Glomar response, a now famous phrase to confirm nor deny the existence of such an operation. This response was designed to maintain the secrecy of the mission while avoiding outright denial, which could have been later contradicted by emerging evidence. The response became a standard reply in cases where the government wished to avoid disclosing sensitive information. It was a reflection of the delicate balance the U.S. government sought to maintain between national security and the increasing public demand for transparency, in the wake of scandals like Watergate and the Church Committee investigations into CIA activities. Over the years, more information about Project Azorian slowly trickled into the public domain. In the 80s and 90s, various accounts of the mission began to emerge, including in books and documentaries. However, it wasn't until 2010 that the CIA officially declassified some of the documents relating to the operation. These documents provided a more detailed, though still incomplete, picture of the mission, including the technical challenges, success of the recovery, and the geopolitical implications. Despite this declassification, much of Project Azorian remains shrouded in mystery. Significant portions of the operation's details are still classified, including the exact nature of the intelligence gathered from the recovered submarine, the full extent of the Soviet response, and the complete list of individuals and entities involved in the planning and execution of the mission. The technical specifications of the Glomar Explorer and the capture vehicle, as well as the specific methodologies used in the recovery, are also only partially disclosed. Due to ongoing concerns about revealing sensitive technological capabilities, that might still be relevant in modern context. The ongoing classification of certain aspects of Project Azorian has fueled speculation and debate among historians, journalists, and intelligence experts. Questions persist about what exactly was recovered from the K-129, whether any significant technological breakthroughs were made as a result of the operation, and how close the U.S. came to achieving its full objectives. Some believe that the operation uncovered more than what has been officially acknowledged, including critical Soviet nuclear and cryptographic materials that remain too sensitive to disclose even decades later. Additionally, the extent of the Soviet Union's awareness and response to the operation is still not fully understood. While some Soviet officials likely suspected the true nature of the Glomar Explorer's mission, the details of any countermeasures they may have considered or implemented remain largely speculative. This ambiguity adds to the aura of mystery that continues to surround Project Azorian, even as more pieces of the puzzle are slowly revealed. So much for joining me on this deep dive into the credible story of Project Azorian. If you enjoyed this video and want to see more content like this, make sure to hit that subscribe button down below and turn on notifications so you never miss it. I'd like to hear your thoughts on this mission. What do you think about the lengths the US went to try to recover a Soviet submarine? Do you believe there's more to the story that's still hidden from public view? Drop a comment below and let's discuss. Intrigued by covert operations on this current season we're on, and historical mysteries? Stay tuned for next week, where I'll explore the fascinating tale of Operation Mincemeat, a daring and deceptive World War II mission that changed the course of history. Don't forget to like and share this video to help spread the word. Thanks for watching. Before we go, we'd like to remind you, if you want to support the channel, you can buy us a coffee at buymeacoffee.com/tcns. Thank you so much for watching and listening, and I'll see you in the next video.